Hello and welcome. In this video we will discuss the power rule of differentiation. The power rule states d over dx of x to the power n is equal to n x to the power n minus 1, where n is a positive integer. Is a positive integer. Now let f of x be x to the power n. Then we know from the formula f prime x is equal to f of x plus h minus f of x divided by h limit as h approaches 0. That is the formula that we'll be using to find the derivative of x to the power n. Now that becomes limit as h approaches 0 x plus h to the power n minus x to the power n divided by h. Now expanding x plus h to the power n using binomial theorem, expanding x plus h to the power n Now the formula that I'll be using to expand x plus h to the power n using binomial theorem is this one. The formula is x plus y to the power n is equal to sigma k equals to 0 to n k x to the power n minus k and times y to the power k. The sigma indicates that it's a summation, which means as k runs from 0 to n, the first term would be n 0 x to the power n minus 0 y to the power 0 plus, because it's a sigma, it's a summation of all the terms from 0 to n. The second term would be n1 x to the power n minus 1 y to the power n y to the power 1 plus the third term would be n2 x to the power n minus 2 y to the power 2 plus so on up to n minus 1 x y to the power n minus 1. And in each of these terms the n0, n1, n of 2 has an expansion which Let's write this down here. N of k is n factorial divided by n minus k factorial and times k factorial. So if you see n of 2, it means n factorial divided by n minus 2 factorial times 2 factorial. So this is the formula that we'll be using for the expansion here. Now this becomes if prime x equals to limit as h approaches 0 x to the power n plus n x to the power n minus 1 h, because the second term is h here instead of y, plus n times n minus 1 divided by factorial 2 x to the power n minus 2 h squared plus so on, excuse me, plus n x h to the power n minus 1 plus h to the power n. So that's the expansion of x plus h to the power n, and all this minus x to the power n divided by h. All this divided by h. That becomes limit as h approaches 0 because you'll be cancelling out the negative x to the power n and positive x to the power n. You would have n x to the power n minus 1 h plus n minus 1 divided by factorial 2 x to the power n minus 2 h squared plus so on plus n x h to the power n minus 1 plus h to the power n, and all this divided by h. Now as we can see, every term in this expansion has an h, so we can factor the h term out. That leaves us with limit as h approaches 0 n x to the power n minus 1 plus n times n minus 1 divided by factorial 2 x to the power n minus 2, and when h is factored in this term, h to the power would remain plus 1, so on, plus n x h to the power n minus 2 plus h to the power n minus 1. So that is all that is remaining after factoring out the h term. Now, as we can see, every term in this expansion has an h term except the first one. So all these terms except the first one would approach a limiting value of 0 as h approaches 0. Therefore, f prime x is equal to n x to the power n minus 1. So this is the derivative of the function f of x equals to x to the power n, where n is a positive integer.